Hello everyone. So today in this video, we are going to study the fourth module, that is the probability distribution. So here we'll start with the definition of a random variables. So here the definition says that in a random experiment, if a real variable is associated with every outcome, then it is called random variable or stochastic variable. So I repeat the definition. Random variables is defined as in a random experiment if a real variable, so you already know what do you mean by a real variable, that is a variable which assigns a real number is called a real variable, and this variable is associated with every outcome, then it is called a random variable or stochastic variable. So you will understand this definition of random variables better with this example of tossing of two coins. So when you toss two coins at a time, so you will get the outcomes like this. These are the outcomes, that is when you toss two coins, either you may get both heads, or one head, one tail, or one tail and one head, or both can be tails. So this is the outcome of a random experiment. So here tossing of two coins is a random experiment, and these are the outcomes for this experiment. So here capital X and capital Y are called as random variables. So here capital X denotes number of heads and capital Y denotes number of tails here. So here the number of heads, let us denote it by a capital X. Here in our first experiment, that is in our first random experiments, so we have got both heads. So the number of heads will be 2. So let us assign a real number 2 for the random variable x here in the first trial. So next we have a random experiment, in a random experiment of two coins. So either we may get one head or one tail. So here we have only one head, so we have assigned a real number 1 for the random variable x. So similarly in this third trial, so here you can see we have got one tail and one head. Since we have only one head, so let us assign a number 1 for the random variable x in the third experiment. So here we have a fourth experiment. So in our fourth experiment, so we have got both tails. Since we have no heads, so we have assigned a number 0 for the random variable x. So similarly, so here we have a random variable y which denotes the number of heads. So here in our first experiment of two coins, so we have got two only both heads. So here since we have both heads, we don't have any tails, so let us assign a real number 0 for this random experiment. So here in our second experiment, so we have got one head and one tail, so we have only one tail, so let us assign a real number 1 for the random variable y. So here we have a third experiment. In our third experiment, so we have got one tail and one head. So here since we have only one tail, so we have assigned the real number 1 for the random variable y. So similarly in our fourth experiment, so we have got both tails, so we have assigned the real number 2 for the random variable y. So here are the real variables. So for these real variables we have assigned, real variables are associated with every outcome of a random experiment, so we call them as a random variables or stochastic variables in a probability distribution. So here we have two types of random variables. One is, so that is discrete and continuous random variables. So we have two types of random variables, discrete and continuous random variables. So here we'll start with the definition. The definition says that if a random variable take a finite value, then it is called discrete random variable. So I repeat, if a random variable take a finite value, then it is called discrete random variable. So finite value means the number which is countable. Okay, so if the number is countable, that is a random variable which assigns a finite number, then that is called discrete random variable. So here we have a definition of a continuous random variable, that is if a random variable take any value in the interval of real numbers, then it is called continuous random variable, that is in the interval of real numbers. If it takes any of the value, then that very random variable is called continuous random variable. So next we have a definition of discrete probability distribution. So here the definition says that xi into p of xi, this set together is called discrete probability distribution, where p of xi is called probability probability density function or probability mass function if p of xi is greater than or equals to 0, or summation of p of xi should be equals to 1. I repeat, xi into p of xi is called discrete probability distribution. This set is called discrete probability distribution. In this, p of xi is called probability density function or probability mass function if it satisfies these two conditions, that is all the p of xi's must be greater than or equals to 0. It means it should take all the positive values. And we have a second condition, that is summation of p of xi must be equal to 1. That is summation in the sense the sum of all these values must be equal to 1. So next we have a note. In the note, so we have three formulas. So in the first note, so we have a formula of a mean, so which is denoted by mu, so which is equals to summation of xi into p of xi. And next we have a variance which is denoted by capital V, so which is equals to summation of xi minus mu the whole square into p of xi, or we have another formula, summation of xi square into p of xi minus summation of xi into p of xi the whole square. So you can use any one of these formulas in calculating the variance. So here we have a third formula, that is the standard deviation, so which is denoted by sigma, which is equals to square root of the variance. So here in the notes which I have sent previously, here we have a in that we have a derivation for mean, variance and standard deviation, so you can just go through that notes for the further studies. So next we have, so we are going to start with the problems based on these three formulas here. So you can see problem number 1. Here we have a first problem. The problem is the probability distribution of a finite random variable x is given by the following table. Determine value of k and find mean, variance and standard deviation. I repeat the problem once again. The probability distribution of a finite random variable capital X is given by the following table. Determine the value of k and find mean and variance and standard deviation. So here we have a table of values for xi's and p of xi's. So here the xi's are given by -2, -1, 0, 1, 2 and 3, and p of xi. P of xi is a probability mass function or probability density function. So p of xi are zero point 0.1 k, zero point 0.2, 2k, zero point 0.3 and k. So here this table is called the probability distribution of a random variable x. So this table will call it as a probability distribution. So and p of xi is a probability density function or probability mass function. So here in this problem we have to find the value of k and we have to find the mean and variance and the standard deviation. So now As I already told you, if you want to say that P of xi is a probability density function or probability mass function, it must satisfy these two conditions. That is, P of xi must be greater than or equals to 0. So here, if you observe these values, these are all positive values. So obviously, this will be greater than or equals to 0. This condition is satisfied by the observation. And we have a second condition, that is summation of p of xi must be equal to 1. Summation of p of xi in the sense the sum of all your p of xi values. That is, you should add all these values. That is zero point 0.1 plus k zero point 2 plus 2k plus zero point 0.3 and plus k, and which will be equals to 1. So here you have which is equals to 1. That is sum of all your p of xi. Here we have written a sum of all the p of xi values, and we have equated it to the 1 according to the condition, and add all the numbers here. zero point 0.1 plus zero point 0.2 and then zero point 0.3 is zero point 0.6 plus, now add all the k's, that is k plus 2k plus k is plus will be equals to 4k. That is, we have zero point 0.6 plus 4k, which is equals to 1. So 4k is equals to, so 1 minus zero point 0.6. So you can transform this zero point 0.6 to your RHS side. So you'll get 1 minus zero point 0.6, and we are finding the value of k. So take this 4 to other side. So I'll be having k is equals to 1 minus zero point 0.6 by 4, so which will be equals to zero point 0.1. So the value of k is equals to zero point 0.1, zero point 0.1 here. So here we have determined the value of k. So next we have to find mean, variance and standard deviation. So we'll go back to the previous page. So here we have the formulas for mean, variance and standard deviation. So we'll use these three formulas and we'll calculate the mean, variance and standard deviation for this probability distribution. So here, to find this one, so let us write this probability distribution once again. That is, in the first column, so we have written all the xi's. So xi's are given by -2, -1, 0, 1, 2 and 3. So this is already given in the problem, and these are the p of xi values. So we'll go back here. You can see this is the p of xi's which is given in the problem, but they have not given the value of k. We have to find the value of k. So here we have found the value of k as 0.1. Substitute the value of k as 0.1 in this p of x's. So you are going to get this column, that is zero point 0.1, zero point 0.1, 0.2, 0.2, 0.3 and 0.1. So we'll get this column after substituting your k value, that is k as 0.1 in this row, in the p of xi's row. So you can see here. So in this So in this p of xi's row, substitute all the value of k as 0.1. So you're going to get this column: 0 0.1, 0 0.1, 0 0.2, 0 0.2, 0 0.3 and 0.1. So next we have the column of xi's into p of xi. So this is actually required because to find the value of mean, so we have this formula. So what is the formula we have? We have the formula as summation of xi into p of xi. That is, first multiply your xi and p of xi values and do the sum of this column. So you are going to get the mean value. Okay. So for that reason, so here we have found xi into p of xi's. So that is, you have to multiply this xi and p of xi values. That is, -2 into 0.1 is given by minus zero point 0.2 and -1 into 0.1 is given by minus zero point 0.1. Like this, add these two columns. So you are going to get all your xi into p of xi values, and the sum of all these values will be equals to mu, that is the mean, which is equals to summation of xi into p of xi. So you will get the answer as 0.8. So you have to add all these values. So the sum of these values will be equals to 0.8. So this is the mean for the given problem. So next you have to find the variance. So here we have the formula of the variance, that is summation of xi minus mu the whole square into p of xi. You can use any one of the formula, so which we have written in the note. So whichever is convenient for you, so you can make use of that formula. Okay, so here we have summation of, this is the formula for the variance, which is equals to summation of xi minus mu, in the sense the mean, so which I've already found, that is the value of mean is 0.8 the whole square into p of xi. So here you can see I have substituted the value of mean as 0.8. So now what you have to do is substitute all your xi values and p of xi values, and then calculate using your calculators, that is here you can see. So here this is the mean value 0.8. So substitute all your xi values and then p of xi values. Here you can see xi and p of xi values. So substitute in this formula. So you're going to get this answer. So for each of these values you have to calculate in the same way, that is it's very simple. You can just substitute xi and p of xi values. So calculate by using your calculator, you're going to get this answers, and the sum of all these values will give the value of the variance, that is 2.16. You can see here the sum of all these values will be equals to 2.16. So this is the formula of the variance. So variance v is given by 2.16. So next we have a standard deviation. Standard deviation formula is given by square root of the variance. So here I have to put equal to sign. So you can just put it as equal to sign here. Standard deviation is equals to square root of variance, which is equals to square root of, we have got the value for the variance as 2.16. So this will be square root of 2.16, which will be equals to 1.469. Okay, so I will come back to the problem. See, for this distribution, that is for the probability distribution, we have found the value of k, we have found what is the mean, we have found the variance as well as the standard deviation. So we have done with the first problem. So next problem is given by the probability distribution. So here we have a second problem, that is the probability distribution of a discrete random variable x is given by, so here they have given again x and p of xi values, that is xi values are given by 0 1 2 3 4 5 6 and 7, and p of xi values are given by 0 k 2k 2k 3k k square 2k square 7k square plus k. Okay, so here you have to find what is the value of k, same like previous problem, and probability of x less than 6, probability of x greater than or equals to 6, and probability of 3 less than x less than or equals to 6 here. So as I already told you, if you want to say this probability density function or probability mass function, that is p of xi is a, if you want to say p of xi is a probability density function or probability mass function, so it must satisfy these two conditions, that is p of xi must be greater than or equals to 0. So here you can see you'll get all the positive values obviously, and summation of p of xi is equals to 1. So by using this formula you can find the value of k, that is sum of p of xi. So you can add all the p of xi values. So here we have a p of xi values, so you can add them, that is 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k. So the sum of all these values must be equal to 1. Okay, so here first add all the k values. So here we have k and then we have 2k. So k plus 2k will be 3k plus 2k will be 5k. 5k plus 3k will be 8k, and then we have one more k here, 8k plus k will be 9k, plus after that I'll add all your k square values, that is k square plus 2k square is 3k square, 3k square plus 7k square will be 10k square, and here we have 0. Okay, so if you have any other number, so you can just add that number. We have 0 and we have a real number here 1. So let us take this 1 to other sides, that is minus 1 is equals to 0. So let us rearrange and write this equation once again. So you are going to get 10k square plus 9k minus 1 is equals to 0. So which is a quadratic equation. So you can find the roots of this equation by using your calculators. So you are going to get the roots as k is equals to zero point 0.1 and minus 1. So we have two values for k. So in this you can choose any one value, that is you have to choose the positive value. Say, because if you want to say p of xi is a probability density function, so all the values must be greater than or equals to 0. So if you choose k as minus 1, so you are going to get the negative values after substituting in your p of xi. So you have to choose k as zero point 0.1. So I have taken k is equals to zero point 0.1. Now substitute the value of k in your p of xi. So you're going to get a new table like this. That is the probability distribution for the given problem is given by xi's. These are the xi's values which is already given in the problem. And these are the p of xi values. So here in this problem, in the given problem, in the p of xi row, substitute your k value. So you're going to get these values after substituting the k values. That is 0 0.1, 0.2, 0.2, 0.3, 0.01, 0.02 and 0.17. Okay, so now we have to find, after finding the value of k, what you have to do? You have to find what is probability of x less than 6. Okay, so these are the x values they have given, all x size x values. So here to find probability of x less than 6, so you have to see this symbol very importantly. You have to consider all x values which is less than 6. So you should not include 6 because we don't have equal to sign. So the number which is less than 6 is 5. You can see here we have 6, less than 6 number will be 5. So you have to take all the numbers till 5 and you have to add them. Okay, so here you can see first you have to take probability of x is equals to 0 plus probability of x is equals to 1 plus probability of x is equals to 2 plus probability of x is equals to 3 plus probability of x is equals to 4 plus probability of x is equals to 5. So I have taken all the numbers which is less than 6 and the probabilities of these numbers are given by the second row, that is probability of x is equals to 0 is 0 plus probability of x is equals to 1 is zero point 0.1. You can see 0 plus zero point 0.1 and probability of x is equals to 2 is zero point 0.2 plus probability of x is equals to 3 is again zero point 0.2 plus probability of x is equals to 4 is zero point 0.3 plus probability of x is equals to 5 is 0.01. So here they have given all the numbers. So you can just add them and you're going to get the answer as zero point 0.1. Okay, next we have to find what is probability of x greater than or equals to 6. So here you can see the inequality, it's greater than or equal to 6. In the sense you have to consider all xi's which is greater than 6, and since we have equal to sign, you should include 6 also in this distribution, that is which is equals to, you have to take the numbers from 6 including 6 and the number which is greater than 6. So here you can see we have only one number which is greater than 6, that is only 7. Okay, so you have to take both these two numbers because we have the inequality greater than or equals to 6, that is the number which is greater than 6 is probability of x is equals to 7. Since you have equal to sign, you have to include 6 also, that is probability of x is equals to 6. So and one more thing, if you don't have this equal to sign, that is greater than or equal to, if you have only greater than 6, then you have to take only probability of x is equals to 7. So you can just exclude this probability of x is equals to 6 only if Instead of this condition, if you have only greater than 6, since we have greater than or equals to sign, we have to consider 6 also. That is probability of x is equals to 6 plus probability of x is equals to 7. So probability of x is equals to 6 is given by, here you can see, probability of x is equals to 6 is 0.02 and probability of x is equals to 7 is 0.17. So add these two numbers, you are going to get the answer as 0.19. So next we have to find what is probability of 3 less than x less than or equals to 6. So here these inequalities, you have to observe these inequalities, which is very important. So here my x varies from 3 less than x less than or equals to 6. That is, you have to choose the numbers between, not choosing, you have to take all the numbers between 3 to 6, and you should not include 3 because we don't have equal less than or equals to, we have only less than 6. So here we have less than or equal to, so you have to include 6. I hope you are understanding. So here you can see we don't have equal to sign, so you should not include 3, and here we have equal to sign, less than or equal to sign, so you have to include the number 6 also. Okay, so here after 6 we have sorry, after 3 we should not include 3. After 3 we have 4, 5, and since we have the inequality less than or equals to 6, you should include 6 also. So we'll come back here. You can see probability of x is equals to 4. So we have not included 3. So we are starting from x is equals to 4 and probability of x is equals to 5 plus probability of x is equals to 6. Probability of x is equals to 4 is given by 0.3 plus 0.01 plus 0.02. So you can just see this number. Probability of x is equals to 4 is 0.3, probability of x is equals to 5 is 0.01, and probability of x is equals to 6 is 0.02. Okay, yeah, you can end it here. Probability of x is equals to 6 is 0.02. Add all these three numbers, you are going to get 0.33. So now we have done with this problem, that is, we have found the value of k, probability of x less than 6, probability of x greater than 6, greater than or equals to 6, and probability of 3 less than x less than or equals to 6. And we are going for